Hi Mike, so I'm looking at page 144, number 6a, and that's a pretty basic derivative. So I'm not sure where you're having problems in coming up with the answer. It's just a straight power rule, right? Minus 20x to the negative 6. This thing here is a constant, right? Pi is just 3.14 and the derivative of a constant is 0. So that's our derivative, which of course we could rewrite like this. So then I assume you're thinking, well, that doesn't match the answer in the back of the book, but this is where you need to use some problem solving skills and you need to get more comfortable with your algebra. Okay, this is fine, this is the right answer, but the answer in the back of the book, I think, says negative 5, 3x to the 8, is it plus 20, over x to the 6. And you should be able to figure out that these things are the same. The answer in the back just has a common denominator of x to the 6, and I could easily take my answer here and take this thing and multiply top and bottom by x to the 6 so that I'd have a common denominator. So it'd be negative 15 x to the 8 over x to the 6 minus 20 over x to the 6, which is just negative 15, 8x, x to the 8 minus 20 over x to the 6, and then I can common factor out a negative 5, and I'm left with that should be plus 4. Okay, so the answer in the back of the book, I guess, was plus, oh yeah, I'm checking, it was plus 4. Okay, so they're the same thing. So that wasn't, this algebra was not too hard to do. You should be able to figure that out. Okay? The second question, B. I got a slightly different answer than the back of the book. So my answer for g prime of x was equal to 3, 8x squared minus 3x squared, 16x minus 3. So that was a basic chain rule question. Check if yours matches this, and if it does, you're okay. All right? Okay, similarly, number C, or letter C, the answer in the back of the book is a very simplified one, and the author used some algebraic skills to get there. If you can't figure out how to get from your answer to their answer, that's okay. We can work on algebra skills more next unit, but there are ways to figure out if your answer is right. Try subbing in a value like x equals 2 into your answer, and then sub that same number into their answer, and see if it comes out with the same y value. And if it does, it probably means you have the right derivative. You have to use some problem solving skills here to verify your answer. Okay? So this was the original function. It looks like you needed to use the product rule because you have two things here, and then within the product rule, to find the derivative of this one here, you'll have to use chain. So I can do it quickly here. I do the derivative of this first one, which is going to give me 1/2 9 minus 2x to the negative 1/2 times the derivative of the inside, negative 2. And then I'll keep the original second half of the function. And then I'll add that to the original first one times the derivative of the second one, which would be 2x plus, and that thing here was 2 times x to the negative 3, so that becomes, looks like negative 6 x to the negative 4. Okay, so that is your unsimplified derivative. To simplify it, you'd want to bring this term into the denominator. You'd want to cancel out those 2's and have a negative 1, right? And then over here, you'd want to bring that into the denominator. And then I'm sure what they did in the answer in the back of the book was then they went ahead and created a common denominator between this term and this term, added them, factored, simplified. that might be too much for you to do right now, and that's okay. For this test, I'd accept something like this as long as the negative exponents and the fractional exponents are rewritten as positive exponents and roots. Okay? And how about the last one? D. F at x equals 3x minus 2 over the square root of 1 minus x squared. And I would definitely use the quotient rule for this one. Low d high minus high d low over low low, because you've got a polynomial over a polynomial. So low d high minus high d low, we know that's going to be 1/2 it's 1 minus x squared to the negative half, and then I'll have to multiply that by the derivative of the inside, which is negative 2x. And then that's all over low low. Okay, so again, that's the basic derivative there. And then this could be simplified a little more. For instance, I could even just minor simplifications. I'll write the 3 out in front, and then I'd say minus. And let's see, this 2 here will cancel out with that 2 there. And then this negative, I can combine with that negative so that it could become plus. And then I could write this x out in front here, just to make it look nicer. And then on the bottom, of course, this squared is going to cancel out with the square root, so I'll just be left with 1 minus x squared. Now that's still not fully simplified, but if I want to check if this answer matches the one in the back of the book, once again I could pick a value like x equals -1 and sub it into both and see if they match. Another option, which I did when I was solving this for you, was I put it into GeoGebra. This up here, f at x, was the original function. This here was the answer they gave me in the back of the book, and this here was the answer that you and I just came up with. And you'll notice that if you graph f prime of x, the answer in the back of the book, it looks like that. And if you graph the answer we came up with, I wrote here g of x, but it's actually our derivative, g prime of x, you'll see that it's actually the exact same graph as the f at x, f prime of x one. So that means they're the same function, just written in different ways. Okay? And it is some pretty complicated algebra to get from the answer you might have to the answer in the back of the book. So don't worry about that so much right now. Okay? Hope that helps, Mike.